Welcome everyone to another lecture on programming in C++. Today we are going to talk about polymorphism. In this lecture, we are going to explore different concepts of polymorphism. We are going to compare compile time polymorphism and runtime polymorphism, and we are going to analyze different polymorphism techniques, better to say different compile time polymorphism techniques available in C++ like operator overloading, function overloading, etc. So let's start. Polymorphism means having many forms or having different forms. So for example, we can have a person that can show different characteristics depending on the situation. Like a man at the same time can be a father, at the same husband and employee. So if he is in its office, then a man can showcase the properties of an employee. If he is in house, he can be a father or a husband. So same person can possess different behavior in different situations. So this kind of activity is known as polymorphism. C++ actually supports this kind of activities and lets us create functions basically. So one function, suppose a function name called area. So this a function name called area. So this function should be able to find the area of any shape, like being it a triangle, uh, being it a say rectangle or even a circle. So how they are going to distinguish between each other? So it depends on whichever value or what are the values that we are giving as an input to this particular function. Depending on that value, it will determine the area of triangle, either the area of triangle, either the area of rectangle, either the area of circle. So similarly, another example in C++ could be this operator plus. So if you give two integers, say 15 and 20, so plus operator try to find out the sum of this number. But if we have a class called complex that can handle complex numbers, so what polymorphism gives us, or what is the theory of polymorphism, is that this plus operator should also be able to handle complex numbers as well, like they are normal integer numbers or normal any primitive data type. So that is the fundamental idea of polymorphism. Like one function or one operator can do multiple jobs depending on whatever value we have fed to that particular function or operator. So there are two type of polymorphism available in C++. One is called compilation time polymorphism, another one is called runtime polymorphism. In compilation time polymorphism, which version of some object or some entity is going to be selected is selected on the compilation time, or the time or at the time of compilation. Whereas in case of runtime polymorphism, the object that is going to be used for a specific purpose is decided at the time of running, that means at the execution time. So there are two applications of polymorphism, compile time polymorphism in C++. They are called function overloading and operator overloading. So we are going to discuss them in this class, and in the following classes we are going to define runtime polymorphism. Like runtime polymorphism provide the features like function overriding and virtual function. So we are going to discuss them in the later classes. So in today's class we are going to deep dive into the function overloading and operator overloading in details. So compile time polymorphism. So as the name suggests, it is a polymorphism that actually selects the entity that is going to be used, or the function or the operator that is going to be selected at the time of running. So this type of polymorphism is called early binding or static binding. So which version of the overloaded function are going to be used decided at the compilation time. And this compile time polymorphism can be or can be achieved through function overloading and operator overloading. That is the concept, or that is the topic for our today's discussion. In runtime polymorphism, also known as late binding or dynamic binding, here the version of function or version of the entity that is going to be selected is decided on the time of execution. That means when the program is going to be executed at that particular time, uh, the following version or the version of the function or the version of the entity is being selected. So that is not known at the time of the compilation time. So that's why they are called the late binding or dynamic binding, and can be achieved through function overriding or virtual functions. So in consecutive lectures, we are going to learn about them. So now comes function overloading. So what is that? So function overloading means two or more function with the same name. So in C, we don't have this kind of structure. That means we cannot have two functions having the same name. But C++ allow us to have uh, functions that has same name, and they are distinguished by the number of arguments, the type of the arguments, and the sequence of the arguments. So we are going to discuss about them and following slides. So which operation will be performed by, or which of the functions will be selected, depends on the inputs to the functions, and return type cannot distinguish between two functions with same name or argument. Like, so these three things can only distinguish two functions. So name, if two functions have same name, then we must have one of them to be mismatched with each other. Then only we can distinguish between the two functions. And return type cannot distinguish between two functions. What does that mean? So for that, we have to follow this particular example. So we have three to 5 and 6. So we have 6 function declarations, and among them this 5 actually follows the rules of function overloading, whereas this one does not follow the rule of function overloading. Let's check why. So we have 5 different functions here, though the name of the functions is same, but the operator list of arguments is different. Like this one doesn't have any argument, this one has two arguments, this one has two arguments, this one has two arguments, and this one has two arguments. So the first point is number of arguments. So depending on number of argument, we can distinguish them. So clearly we can distinguish this 4 with this one, because this one doesn't have any argument and this one has two arguments. Now they are dependent on type of the arguments. So let's check it. So we have int, we have int, we have int float, we have double. So we can say that from this particular scenario of type of arguments, we can say that here are two ints, here are one int, one float, one int, one float, and two doubles. So these two are clearly different from these two. So this is function overloading. Now for the sequence of the arguments, so as you can see, float int and int float, they are different sequence. So these functions are, all of them can be written or can be overridden. So they are the overloaded functions of single function name called add. So let's take an example. So function overloading depending on the number of arguments. So what we have here, so we have two different functions, int add with three arguments, int a, int b, and int c. So this is 1, this is 2, and this is 3, and we have int add with 1 and 2. So these functions return the sum of or addition of these three integers, and this add function actually returns the addition of two integers a and b. So in the main function, we have x is equal to 1, y is equal to 2, z is equal to 5. And now we have called add xy and we have called add xyz. These two are valid statement because xy has single argument and xyz has triple argument. So that's why it can distinguish between these two functions, and whenever we call this add xy, it will call this version of the function or this version of the add, and when we are calling add xyz, it will call this version of the function. But if you call this one uh, x only, So it cannot be identified by the compiler because we don't have any function definition that can accept one single integer. Also, if we have suppose float add int a and int b here, and we suppose return a plus b. This is also not valid. Why? Because return type cannot distinguish between functions. That means only the function signature is required. That means function name followed by the type of the arguments. Say int. So this thing can only distinguish between different overloaded function. So return type is different. That doesn't mean that two functions are different. That means the compiler will give an error that you are trying to redefine this particular function add int. So that is the function signature, and that is being checked when differentiating between different overloaded function. Then depending on the type of argument, so we have this particular example. So here we have float a int b and int a int b, and this function returns float and this function returns int. So return type doesn't matter for us because return type cannot distinguish two functions. So the function signature is different, add float int, add int. So function signature is different. That means these two are valid overloaded function of add. Now we have another variable f is equal to 2.5, that is a floating point number. So now if you call a add cout add xy, so when we call add xy, what is happening here? So x and y both are integers, so it will check uh, or it will actually access this particular function. So what will happen? First of all, it will check for the number of arguments. So here we have number of arguments 2. So here also we have number of arguments 2. Here also we have number of arguments 2. Now, as both the functions has number of arguments 2, it will check for the type of their arguments. So now, when checking the while checking the type, it will stuck here that this is the actual function that is being called by this method. So what will be the output here? X plus y is equal to 3. And when we call it add f comma y, so it will again check for number of arguments. So it will find 2, and for that it will check the type of the arguments. So that is float int, and that is found for this particular definition. So it will return f plus y, that is equal to 2, so 4.5. So that will be the output. Now consider this particular statement x comma y. Now what is wrong here? So we have two arguments, so that is fine. So both of them has two arguments. Now we have x comma y, that is an integer comma float. So this particular function, what is the signature here? It's float comma int. And for this particular function, what will be the signature? It is int comma float. That means though both of them has one int one float, but they actually not same, they are different because the function signature is different. So int float and float int, they are different. So sequence of argument is also important, that we are going to see in our next example. So function overloading depending on the sequence of argument. So now we have this float a and int b and int a and int b. So we have these two versions. So now what we can do, we can do add fy and add xf. So this is fine because add fy, so this is float and integer, so that will invoke this function, and add xf, that will invoke this function because it is integer and float. Now consider this function add fg. So this is add float and float. So we don't have any version of this function add float. That means this function call to this particular function will not be recognized by the compilers. What we have to do here to make it recognizable, so we have to add this add float a and float b and return a plus b. So if we add this particular function definition, then only this particular function will be recognized. So in these three methods, actually function overloading detects for overloaded function and checks for which version of the function is going to be called. There is another way of determining which function or uh, which function will be called. So that is called type promotion. Type promotion. So what is here? Let's check the example first. So we have one function definition only. So float add float a int b, and we have here, this is the float variable, this is the integer variables x y z, and we have here the signature is add. So for this is add float integer, and for this, so x and y both are integer, so this is integer and this is integer. And for this one, we have add z, that is integer and float. And for this one, we can just write the signature as float int. Now, as we can see, only one of these functions has matched with this version. So this one is correct. We are 100% sure of that. And this one, we have already seen that if this sequence is different, this function will not work. So this function will not work. Okay. So now what about the middle one where we have int and int? Now, first of all, compiler will try to find a match to int and int. If not found, it will try to find a promotional match. Promotional match in the sense, here we have float and here we have int. So int can be automatically promoted or automatically converted to float. We have learned that thing in type conversion and typecasting, where lower level variables can convert it into upper level variables automatically. Like if we have double here, so float can automatically convert it to double, int can automatically convert it to double. So here we have float, and we are trying to pass an integer, so integer will be automatically converted into float, and this way this function will also recognize this particular function. So this function call will recognize this particular function. This is called type promotion. So function matching depending on the type promotion. It has some disadvantage as well. We are going to check that. So in of overloading, we have some ambiguities, like compiler could not decide what to do or which version of the function to choose in some particular situation, and we are going to look into that situations now. So first situation is, or first problem becomes when automatic type promotion actually working. So we have some integer variable, so x, y, z, we have some float variable f, and we have two functions. One has float a int b and another one has int a float b. That is fine. That is fine. We can use this kind of statement, cout add say x if Indian. That is fine. So this is float, this is integer, this is integer, this is float. So this function is valid, this function is valid. And what about this one? So in from previous slide, we have seen that by promotion, this function should not have any problem, but that is the problem here. We have two different functions. So x can be promoted, this integer can be promoted to a float. This integer can also be promoted to a float. So now for this particular function call, we have two different variations, and compiler will not able to decide and throw an error that ambiguity in overloading function, ambiguity in int. So that will be the error for this particular message. That means this time compiler actually cannot decide what to do. If we don't have this, only we have this function, then only this function will work, this function call will work, this function will not work, but this function will work. But if we have both of them, first two will run without any error, but third one will give us a ambiguity problem. So this particular function will not run. Another example of type promotion error can be found here. So we have float int and int. So these are the function definition of add, and we have a call float int because x y is int and float if is float. So these two statements are correct. Now what about this one? So we have cout add 2.5 and z. So 2.5, it may seems like this is a fractional number. Obviously it is a fractional number, and float is used to store the fractional numbers, and z is itself an integer, so that is fine. So from a glance we can say that this function should be called, but actually that is not going to happen. So all the constants, all the fractional constant in C++ is considered as a double, and double cannot be automatically converted to float. So that's why this particular function cannot be executing. So if this is double, then this function is fine and this function is also fine. But if it is float, this function is fine, but this function is not fine. It will give add double int type promotion error. That means we cannot promote, or this particular value, double value, cannot be promoted to float. So this will give an error. Now, another type of ambiguity can occur when we have default arguments. So we have this particular function that has three different values or three integers as an input, and we are trying to find out the sum. So that is fine. And then we have this particular function where we have given two numbers or two integers as an input, and the return is the summation of two numbers. Now, what will happen if we have x, y, and z? That means this one, for this particular function call, this function will be invoked. But whenever we are trying to use this particular function, cout, add x and y, it cannot recognize which version of the function should be called, because for this particular default argument we can actually use two arguments. So if this function is not available here, this function will work fine, and if this function is not available here, if this function is not available here and only we have this function, then this function call will works fine, but at that particular time this will not work. So what is happening here, whenever you are trying to call this xy, because it has a default parameter, so in case of default parameter we can actually give all the parameters, or we can just remove the default parameters from the function, from the actual parameter. So that's why this particular function call cannot recognize or cannot distinguish between these two calls. So this is called default argument ambiguity in case of overloading. There is another ambiguity when we have some pointer variable or reference variable. Suppose we have this void add int a and void add int star a. So these two cannot be recognized, because when we actually try to find out the signature, it is int and then again it is also add int. So both of them have similar signatures. That's why this pass by pointer or pass by reference will not work in as a overloaded function. So these two types are not cannot be distinguished as different type. They are actually same type. So this type of functions cannot be called overloaded function, and they will give ambiguity to the compiler. So for a practical example, we might consider a class called shape class that has three overloaded functions: double area, double radius, double area, double length, double width, double area, double side 1, side 2, and side 3. So this particular function that takes one argument or one double argument will find and return the area of a circle, and this one will find the area of a rectangle, and this one will find the area of triangle. So let's move into the code to check what exactly is happening in this particular code. So we have this particular code area. So we have this class shape. So we have defined the class shape, and inside the class shape, we have kept everything. So we have not done any operations for the class or any function definition of the class outside the class. We have kept everything inside the class. So that doesn't create any problem. So what we have in the public section, we have three different functions. So one, to find out the area of a circle, so that is the formula 22 by 7, that is pi, multiplied by r multiplied by r, that is the pi r square. We could have used math.h function. So math dot from we can use the pow function from math.h, but we have not used this for this particular case. So we have this particular function area, and now we overload this area function with another function definition where we have two double values a and b, and we are returning a multiplied by b. Uh, that is the area of a rectangle. So if we have a rectangle here, so this is a and this is b, so the area will be a multiplied by b. So that is the formula. So we have found that formula here, or we have implemented that formula here. And now for triangles, we have this particular formula. I hope you guys can remember. So if you are given three sides, suppose A, B, and C, so you first found A plus B plus C divided by 2, and the area will be root over of S into S minus A into S minus B into S minus C. So we are going to implement that. So that is implemented here. So double S is equal to A plus B plus C divided by 2, and area is equal to square root of, so from here to here we are going to square root S into S minus A into S minus B into S minus C, and we are returning that particular area. Now here is the catch, we have done something else as well here. So we know that if three sides of a triangle is given, we have a formula to check whether that sides actually form a triangle or not. Like if we have given 3, 4, and 5, so we know that this can form a triangle. But if you are given 3, 20, and 5, so there is no way you can build a triangle with this. So if we can't build a triangle with this, what will be the output? That means area is 0. So that thing is mentioned here. So to find the area of a triangle, we must check whether that three sides can actually form a triangle. If not, then we will return 0, and also we will write a message that triangle is not possible with these sides A, B, and C. So what is happening here? So the formula is, or the theory is that the sum of any two sides must be equal to the third one. So 3 plus 4 must be equal to 5. 4 plus 5 is equal greater than 3, and 5 plus 3 has to be greater than 4. If this condition is satisfied, then only we can say the triangle formation is formed. So if this condition is not satisfied, so what I have done, I have written not these conditions, a plus b greater than c, and b plus c greater than a, and c plus a greater than b. So if these conditions are not satisfied, then we can say that triangle is not possible with the sides, and we are returning 0. That means the area of the triangle will become 0. And in any other case, this particular area or this particular codes will be executing and try to find out the area of the triangle and return that particular area. So what we have done inside the main, let's check it. So inside the main, we have created an object shape, and we have printed the area of circle with radius 5 and called s dot area 5. Then we have printed area of rectangle with length 5 and width 3, and we have called s dot area 5 comma 3. And then we have area of rectangle with sides 5, 4, 3, and we have called s dot area 5, 4, 3. That means three variables or three double or integer variables, doesn't matter, because integer can be automatically promoted to double, no problem on that. And area of rectangle with side 5, 20, and 30, and s dot area is 5, 20, 30. Now what is happening here, the area is same, that means the function name is same. What is different is the input to that particular function, and depending on input it actually performs different operations, but the name of that particular function is same. The name is area. So let's just execute it. So as we can see the results from here. Area of circle with radius 5, 78.5714. Maybe it is correct. Pi r square, maybe it is correct. We don't want to calculate it. So let's just find the area of a rectangle. That will be easy for us. So that is the area of rectangle with length 5 and width 3 is equal to 15. Now it is written area of rectangle with sides rectangle. So that is my mistake. It should be here. I should write triangle. So that is the mistake in my part. So area of triangle with sides 5, 4 and 3 is equal to 6. And triangle is not possible with sides 5, 20 and 3. That's why area of rectangle with sides 5, 20 and 3 is equal to 0. That means our functions are actually doing what we are intended to do. So now I'll just change it to triangle. So from this function, I guess the function overloading is clear. So the idea is simple. Just we want to use the same function name, but it should work or it should find the area as well. But depending on the input, it should find the area of different shapes. That is what we want from function overloading. Now we have another concept that is extremely new and completely new to you guys, that is operator overloading. We can actually change the behavior of the operator. That means suppose we have a plus operator and by default it can actually add two numbers. We can make that plus operator add two strings as well. That means we can write, say we can have two character arrays and we can put a plus operator between those two arrays or two character arrays to form a concatenated character array, or we can have a user defined class for complex number that can actually manipulate or that can handle complex number, and we can put a plus sign on two complex numbers to add two complex numbers. So that is how operator overloading works. So what it does, operator should treat objects as normal behavior, normal variable. That is the main fund or main idea of operator overloading. That's all the operators should work on every object, every user defined types. So make operations operator operate on user defined object. If we have a class complex to handle complex number, plus operator should add two complex number as it does for any integer or real number. So that was I was trying to say. So what we can do, we can redefine the existing operator definition. For that, we have to use this kind of structure: return type, operator, sign, arguments, and then inside the argument we have to write our code that will be executing when that particular operator is going to be executed. And we have to be careful with the return type. We should maintain the return type for operator overloading so that they can be cascaded. So I will come to that in this particular code. And also friend function can also be used in case of operator overloading. We are going to take a look at those examples in this example code. So uh, we have a class complex that has two floating point numbers, real and imaginary. So they are the private numbers, private properties of the class. And in the public section, we have two constructors. One is complex, normal constructor or default constructor that initializes real number and imaginary number to 0. And suppose they should be float actually. So we have this parameterized constructors that actually initializes the value of real and imaginary. Uh, so that is x and y. We also have another method void input, so we are not going to use that particular function. So it actually takes the input of real and imaginary part of a complex number, but we are not going to take inputs in this particular program. And also we have, okay, we have this display function. So this display function will display the complex number in complex format, like the real number plus imaginary number multiplied by I. So that is the actual complex number style, like something like this, a plus bi. So this way, this particular function, display function, will print the imaginary number. So if imaginary part is 0, it will print only the real part. If the imaginary part is if there is any imaginary part, then it will print a plus I, where a is the real part and b is the imaginary part. So that is maintained, or how they look, it is maintained by the display function. Now we have a operator overloading. So what we want to try to overload this plus operator. That's why we have written operator plus. So it is like this function definition. So instead of function name, you are writing operator and operator sign. So the return type. So whenever we actually do a plus b or 5 plus 2, suppose. So this is integer, this is integer. So the resultant value from this plus operation will be an integer. Similarly, if we add two complex number, the resultant value should be a complex number. That's why the return type of this overloaded plus operator will be complex number. So the return type is complex. Then we have operator plus, and we are taking the object as a reference. And because we don't want to change the object, because we have taken this particular object as a reference, we don't want to change the object by mistake. That's why we have put the constant here. That means this object value cannot be changed. So what we are doing, so to add two complex number, like suppose 2 plus 5i and 3 plus 2i, so it will be this one plus plus and this one plus plus, right? 3 to 5 plus 5 plus 2 7i. So that will be the answer, and that we have done in this particular code. What we have done, so we have taken a temporary complex number that will be our return value. That means that will be this particular value, where in this temporary real number or temporary real part will be the real part. Using that, we have called this particular object or particular operator and the real part of this object, and the imaginary part will be imaginary plus object dot imaginary part, and we have written the temporary object. Now just let's look at how to call those functions. So what we have taken a complex number, another complex number, and a result that is of complex type. We have not initialized it. We have three variables: a is equal to 3, b is equal to 3, 5, and c. So they are the three integers, and we can use this kind of statement: c is equal to a plus b. That is perfectly fine, and that is by default. So what we want in this particular example, or in operator overloading, we actually want uh, to use the user defined types or user defined objects as the same way as we used to use our normal operators for normal variables. So that's why this, to mimic this particular statement, we can write result is equal to complex 1 plus complex 2, where this maybe you can consider this particular statement may be equivalent to complex 1 dot operator plus complex 2. So this might be equivalent to this. So this is something like function call, but because it is an operator, we can write it like this. So this is equivalent to this. That means this complex one is actually that is being accessed by the this pointer. So in this real and imaginary is actually the complex one, and the object that has been passed with the complex number or the add function, and that is this complex 2. That means the object that we have seen in that particular uh, function definition is actually this complex 2. So let us run this particular code. So as we can see, so we have a complex number 1 plus 2i, so that is 1 plus 2i plus 2 plus 3i, that is 2 plus 3i is equal to 2 plus 3, and 3 plus 2, that is equal to 5. So 3 plus 5i. So that is how complex number or addition of complex numbers works using normal member function that is overloaded. So overloaded operator, that is a member function of that particular class. Now we can move ahead. So we can define more functions that will be able to handle complex number very efficiently. So we can add a integer with a complex. So we want this kind of statement. So result is equal to a is an integer value and plus complex. So we can do that as well, but for that we have to redefine the complex number or redefine the plus operator again. So what we have done, so first of all, not consider this, first of all consider this statement. So we want complex number plus an integer. So result will be the complex number plus an integer. B is an integer that will be added by to this complex number. So what we can do here? We have to redefine the plus operator again. So overloading means we can have different type of same name operator of same name with different values. So here in this particular case we have suppose an integer. So instead of complex number, we have now an integer, and this integer will be added to the real number of the output. That's why we have added real number, that is the complex numbers real part plus the x, and imaginary part will be the complex numbers imaginary part, and we have written that. And after this we can actually execute this particular statement. So as you can see, it will be complex number plus integer is equal to the result. So as you can see, complex number 1 plus 2i plus 5, that is equal to 5 plus 1, that is equal to 6 plus 2i. So as you can see, we are able to do it. So now what will happen? What will happen if you want to execute this kind of statement? So what we have seen so far, so this will be this statement can be treated as complex 1 dot operator plus, and there is an integer, so b. So this can be the calling for this particular, or this can be equivalent calling for this particular statement, complex 1 plus b. But what will happen if you want to call this a plus complex 1? So what will happen? It should be something like this. Uh, int or a dot operator plus complex 1. And this kind of statement is invalid. Why? Because a is not an object of complex class. That means we cannot define a member function that will be able to do our task. So what other option we have? Except member function, we have also learned something that can actually manipulate or handle private data of a particular class, that is a friend function. So what we have done for this type of statement here, we have defined a friend function. And in that friend function, we have two arguments. One is the integer, another one is the complex number. Now this problem will be resolved. So what we have done here, so we are defining that function. So we have now integer at first, then complex number, and this way the same operation is performed. So the complex number's real part plus the integer will be the new real part, and the imaginary part of the complex number will be the imaginary part. And then we have written that particular complex number. So what is happening here? So we can see the result of integer plus complex as well. So this is integer plus a complex number, that is 3 plus 1 is equal to 4 plus 2i. So we have able to successfully remastered the plus operator in such a way that three different type of operations are acceptable with objects. So now another interesting thing, just you can cascade any type of or any overloaded operators as well. So a plus b, integer plus integer, and this one plus complex. So integer plus complex, and now this is complex plus complex, complex plus integer, integer plus integer. So this statement is also going to work because we have overloaded successfully, because we have implemented every type of scenario that can be possible with complex number and integer. So we have integer plus complex number plus integer, and complex plus complex, and also integer plus integer is by default provided by the compiler. So all of these possibilities are available. That's why we can execute this kind of statements as well. So as you can see, so this is the result of this much operations. So result plus result or display. So we have displayed the result, and this is the result of all the operations that has been performed using that cascading or sequential plus operations. So this is the end of operator overloading. I hope you have understand the concepts of operator overloading very clearly, because this is very fun, very much fun to learn operator overloading. You can actually overload lots of operator except the size of operator, this scope operator, and dot operator. You cannot overload this dot operator. So there are only few operators that cannot be overloaded, and mostly all the operators are overloadable. So you can overload mostly all the operators except 4 or 5 operators. So this is it for today's lecture. On the next day or next lecture, we are going to talk about inheritance, as well as we are going to continue our runtime polymorphism as well. So after inheritance only, we can actually talk about runtime polymorphism. That's why we are going to learn inheritance, and then we are going to talk about runtime polymorphism. Thank you, everyone.